జూమ్ రికార్డింగా? ఇంకా అది మళ్ళీ అది కట్టాలా? ఇదా తీసేదా అయితే? Just 1 minute, please. I request the students to just wait. The system is very, very slow. Yes. So this is the problem yesterday we have completed at the end of the class. Okay, prove that the following functions do not have absolute maximum and absolute minimum. In that, I have completed the first question. Now let us see the second question. So, okay, first Roman, second question. First Roman, first question. First Roman, second question, sir. First Roman, second question, second bit. F of x is equal to log x. In 0 to infinity. 0 to infinity. Log x means, of course, log x base e only. That is understood. Okay. So we have to prove that this function has no absolute maximum or absolute minimum in its domain 0 to infinity. Domain for this function is open interval 0 to infinity. Say what is f dash x? For log x, what is the derivative? Somebody please respond.
1 by x.
Huh?
1 by x.
1 by x. 1 by x. So it is very, very slow. Log x derivative is 1 by x and x belongs to 0 to infinity. X belongs to 0 to infinity. That means only positive values, is it not? Open 0 to up to infinity positive values means f dash x is greater than 0. F dash x is greater than 0 implies what? F of x is strictly increasing. F of x is strictly increasing. F dash x is positive means f of x is strictly increasing. Increasing. So in its entire domain 0 to infinity, the function log x is increasing, and limit extends to 0 plus. See, 0 to infinity means here this is 0, infinity is this side, plus infinity. So this is the domain. 0 not included, but up to infinity. Now let us see the value of the function when we approach 0 from the right side. That is, limit extends to 0 plus log x. That means log of a very small positive quantity. It is minus infinity. Log x base e. So e power minus infinity will be tending to 0, is it not? So therefore log 0 will be minus infinity. So this limit is minus infinity. So as you approach 0 from the right side, log x value will be tending to minus infinity. So there is no minimum value. Okay. And as you go forward, limit extends to infinity. On the other side of the domain, if you go forward, then log x base e, log x base e is, log infinity is infinity only. So minimum value is tending to minus infinity, maximum value is tending to plus infinity. That means there is no absolute maximum or absolute minimum for this function. You know the graph of log x also, log x will be like this, x-axis, y-axis. So this is the nature of log x, sorry, like this. This is y is equal to log x base e. This point is 1 comma 0 because log 1 is 0. When x is 1, y is 0. So when x tends to 0 plus, that means we approach 0 from the right side. The curve will be going to minus infinity like this. And when you go to infinity on the right side, plus infinity, so this will be going to plus infinity upper side. Okay. So there are no maximum limits or minimum limits. Okay. Let us see the next question. Third bit. Third bit is f of x is equal to x cube plus x square plus x plus 1 in R. In R. So f dash x. Somebody please tell me what is f dash x?
3x square plus
3x
2x.
square plus 2x
square
plus 1.
2x plus 1.
3x square plus 2x plus 1.
1.
This is a quadratic expression. We can see that its discriminant is negative. What is the discriminant? B square minus 4ac. 2 square minus 4 into 3 into 1. So that is 4 minus 12 negative. If the discriminant is negative, according to a theorem, the quadratic expression will have the same sign as a coefficient of x square. X square coefficient 3 is positive. Therefore, the expression also will be always positive.
Positive.
Always positive. That is a theorem. If the discriminant of a quadratic expression is negative, then whatever the sign x square coefficient has, the same sign will be there for the quadratic expression also, whatever may be the value of x. So for all values of x, this expression is positive. So we can prove it in another way also like this. F dash x, I'll take it 3x square by making it a perfect square.
Okay.
So what I do is I take 3 common.
3 common.
In the first 2 terms only, x square plus 2 by 3x. Sorry.
Yes.
Wait, just 1 minute. 2
Take
by 3x.
2 by-
Close the bracket. Plus 1 you write outside, no problem. Okay, in the first two terms only I have taken 3 common. So what should be added inside this bracket here? Something I have to add it here so that the quantity inside the bracket is a perfect square. X coefficient is 2 by 3. Half of that is what? 1 by 3. It's a square I have to add. That means I have to add 1 by 9. Whatever is the coefficient of x, half of it square, I have to add it. So 1 by 9 I have added. So by adding 1 by 9 in the bracket, in effect I have added 3 into 1 by 9 extra. 3 into 1 by 9 extra means that is 1 by 3 I have added extra. Therefore, I have to subtract 1 by 3 to compensate for it. Okay. So that means this will be 3 into now. The bracket is exactly x plus 1 by 3 whole square. So plus 1 minus 1 by 3 is 2 by 3. So what about you this expression? Because it is a square, it is either 0 or positive only. This part is 0 or positive. It is 0 when x is equal to minus 1 by 3. Otherwise, it is always positive only. Okay. So for 2 by 3, we are adding 0 or positive means it is now clearly positive. 2 by 3 plus either 0 or positive quantity is clearly positive. So we have proved that f dash x is greater than 0 for all for all x belonging to R. This is true for all x belonging to R. So R is given as the domain. So that means f of x is strictly increasing. We have shown that f dash x is positive for all values of x, means f of x is strictly increasing on R. Now let us see the limits now. R means what? Minus infinity to plus infinity. Okay. So limit extends to minus infinity. F of x. F of x means x cube plus x square plus x plus 1. So in the limits class, I have told you clearly, when x tends to either plus infinity or minus infinity in a polynomial function, the highest degree term only will stand, all others will be vanishing. They will, we can remove them from the field, battlefield. Only the highest degree term will remain. Because when x tends to plus infinity or minus infinity, compared with the highest degree term x cube, other terms like x square, x and 1 are just negligible. So therefore, so it is limit extends to minus infinity, only x cube we can take. What is minus infinity whole cube? Is it plus infinity or minus infinity?
Minus.
Minus infinity. Minus infinity whole cube is minus infinity. Similarly, for plus infinity also. When x tends to plus infinity also, we have to take only the highest degree term, others we can neglect. So now plus infinity whole cube is plus infinity. So there is no minimum value. We can go up to minus infinity. On the other side, higher side, we can go up to plus infinity. There is no limit. It can be 1 lakh crores, 1 crore crores. Any number is less than another number, is it not? As you go forward to infinity. Similarly, so there are no absolute maximum or absolute minimum for this function. Okay. So we have completed all the 3 bits. Next question is very, very important. I request all the students to carefully follow. This is a different type of question. Let us go forward. Second Roman. This is important. All the students, please listen carefully. This is a different model, second Roman, first question. So if I do one question, solve one question, then you can solve the others in a similar manner. So that is why if, observe the solution for the first question carefully. Find the absolute maximum value Okay, find the absolute maximum value and absolute minimum value absolute minimum value of the following functions the following functions on the domain specified against the function. Specified against the function. Okay. So, first bit. Just 1 minute. First bit. F of x is equal to x cube on -2 to +2. So actually for x cube, the domain is R, complete set of real numbers, but he has given a limited domain -2 to 2 only. In this domain, what you have to find is absolute maximum value and also absolute minimum value in the domain. Okay, what we have to do is, first we have to find the absolute, the method is like this. All of you please listen carefully. First we'll find the local maximum value and local minimum value if there are any in the given domain. Then what we have to do is we have to find the values of the function at the endpoints of the interval. As given -2 to 2 domain, is it not? At -2 we have to find the value of the function. At +2 also we have to find the value of the function. So we have already found the local maximum, local minimum values, and also the values of the function at -2 and 2, f of -2 and f of 2. Out of all these, whichever is having greatest value, that is called absolute maximum. Whichever value is least, that is called the absolute minimum value of the function in the domain. Understood? So we have to find the local maximum, local minimum, and also in addition to that, we have to find the values of the function at the endpoints of the domain. Okay, so that is the important point here. So what is f dash x? Please tell me. 3x square. To find the local maximum, local minimum, we have to equate f dash x to 0. What is the value of x now?
0, sir.
0.
0.
So x is equal to 0 is a stationary point. There, the local maximum or local minimum may be there, or neither of them may be there. Okay. So second derivative test fails here because f double dash x is 6x and the derivative is 0 at x equal to 0. So you have to find sign of the second derivative at x equal to 0, where the derivative is 0. But this is 0. Second derivative positive, then it is local minimum, and second derivative negative, it is local maximum, but second derivative is 0. So the second derivative test has failed. So we have to test what? The first derivative. So 0. Derivative is 0 at 0. Sign of what? F dash x.
F dash x.
What is f dash x? 3x square, you can see. When x is slightly less than 0, negative, x is negative. What about sign of 3x square? Positive only because it is x square. When x is slightly greater than 0 also, 3x square is positive. So that means first derivative is not changing its sign at x equal to 0. Therefore, x equal to 0 is not a local extremum.
Maximum.
Local maximum or minimum? Local
Yes,
extremum.
sir.
X is equal to 0 is not a local extremum. Extremum stands for both maximum and minimum. X equal to 0 is not a local extremum. So actually the function is what? Increasing or decreasing at x equal to 0?
Increasing function, sir.
Increasing. Increasing. Before it is positive, after also sin f dash x is positive. Actually, f of x is increasing at x equal to 0. So the only point where the derivative is 0 is not a local extremum. Now, what else we have to find? The values of the function at the endpoints of the interval. What is f of 0? F of 0,
0, sir.
where the derivative is 0, we have found the value of f of 0. At the endpoints of the interval, what is f of minus 2? Minus 2 whole cube. Minus 2 whole cube. That is minus 8. Sorry, minus 8. What is f of 2? That the other end of the
8.
domain?
8.
2 cube 8. So out of these values, 0 you need not consider. 0 is not a local maximum or local minimum. Out of the two values, minus 8 into plus 8, which is greater? Plus 8 is greater.
Plus 8, sir.
So this is absolute maximum. Absolute maximum. Absolute maximum is also called global maximum.
Local maximum.
Global maximum, it is also called greatest value. Greatest value of the function. 3 names for it. Absolute maximum, global maximum, and also greatest value of the function. Of course, in the given domain, minus 2 to 2. What about minus 8? It is absolute minimum.
Minimum.
Absolute minimum. Absolute minimum is also called global minimum
or
and also
minimum
least
or
value.
least value.
Least value of the function. Least value. That's all. This is the method. Understood? So we have to find the local extremum and also the values of the function at the endpoints of the given domain. And out of them, we have to choose the greatest and the least. Okay. Let us do the next question. Second one. F of x is equal to x minus 1 whole square plus 3 on minus 3 to 1 closed interval. Minus 3 to 1 closed interval. Come on, tell me what is f dash x? For x minus 1 whole square, that
2x minus 2, sir.
2 into x minus 2.
2 into x minus 1.
X minus 1.
Plus for 3, of course, derivative is 0. For 3, it is 0. So, equate it to 0, you will get only one value, x is equal to 1. What about second derivative? First derivative is 2x minus 2.
2, sir. Second derivative is 2.
Okay, okay. F dash x, if I expand 2x minus 2, so second derivative is 2.
2.
2 is positive. Second derivative positive means local minimum.
Local minimum.
Local minimum. Second derivative positive means local minimum. Second derivative negative means local maximum. So at x equal to 1, where the derivative is 0, second derivative, since the second derivative is positive, it has got a local minimum value. So local minimum value is equal to f of 1. X equal to 1, is it not? What is f of 1 in the original function? Come on.
1, sir.
Put
1,
1
sir.
here. Huh?
Okay, 0, sir. 0.
0. In place of x, if you put 1,
So
1 minus
0,
1
sir.
whole square, 3. So this is the local minimum value. Next, what we have to do? At the endpoints of the interval, I told you, no? At the endpoints of the interval domain, sorry, at the endpoints of the domain, so that is -3. One end is -3, is it not? So what is
Yes.
minus f of -3? Let us calculate.
-8, sir.
-3 minus 1 whole square. I'm putting x equal to -3 in the original function. Plus 3.
-8, sir.
Yes, sir.
19.
Oh, sorry,
19.
sorry, sir.
Minus
19.
3 minus 1 whole square is 16. Minus 4 whole square 16. 16 plus 3 19. Now what about the other end? At the other end, that is 1. What is f of 1? F of 1, of course, already we have calculated.
3.
It is 3 only. Now out of these 3, whichever is greatest, that is the absolute maximum. So absolute maximum value is equal to 19, and absolute minimum value is equal to what? 3. That's all. Greatest value 19, least value 3 for this function in the given domain -3 to 1. So let us see the next one. So this is how you have to do this type of problems. Only thing is, apart from local maximum and local minimum, you have to find the values of the function at the endpoints of the interval. That's all. F of x 2 into mod x. On -1 to 6. Okay. Let us write the definition of the function. What? Removing the mod. So, do you remember the definition of mod x? Mod x is equal to x if
X is greater than or equal to 0.
greater than or equal to 0. Minus x if
Less than 0.
Less
x
than
is
0.
less than 0. Remember that. But actually for mod x, the domain is R, but he has given a small interval. In this small interval, -1 to 6, we will take for -1 less than or equal to x less than 0. And other part is 0 less than or equal to x less than or equal to 6. Okay. So this interval -1 to 6, I have divided into 2 parts. -1 to 0, that is the negative part. And 0 to 6, that is the positive part. Okay. So -1 to first part, -1 to 0, negative values. Second interval 0 to 6, positive values including 0, of course, including 0. So what is the definition of 2 into mod x? So in this interval, because x is negative, mod x is -x. So 2 into -x is -2x. Okay. Now the next interval, x is either 0 or positive. So you can see the definition. If x is either 0 or positive, mod x equal to x only. So 2 into mod x is 2x only. Okay. Now let us see the derivative. What is the derivative of -2x? Come on.
-2, sir.
-2. Sorry, -2. For -1 less than
Equal
or equal to x less than 0.
less than
See, at 0, the definition is changing, is it not? There you should not put equal to. Okay. For okay, this is over. Now for 2x, what is the derivative?
2, sir.
2. For here, you have to write only less than, not equal to. Okay. Because 0, the definition of the function is changing. So, like this, you have to write. So at 0, left derivative is -2, right derivative is +2. They are unequal. So we have to, and at 0, the function is not differentiable. You know that 2 into mod x will be something like this. When x is positive, y is equal to 2x straight line. Okay. When x is equal to negative, y is equal to -2x straight line. It is a sharp point. At x equal to 0, it is not differentiable. But anyhow, in this part, -1 to 0, derivative is negative means f of x is decreasing or increasing? Come on, tell me. -1 to 0, derivative is negative. So f of x is decreasing or increasing?
Decreasing.
Decreasing, decreasing. Okay. So from -1 to 0, from -1 value to 0 value, the function is continuously decreasing. And here the derivative is positive 2 for 0 to 6. So f of x is increasing. Okay. -1 up to 0. 0 to 6. See, -1 to 0, the function is decreasing. And 0 to 6, the function is increasing. Means at x equal to 0, there is a local minimum, is it not? Okay.
Yes, sir.
From -1 to 0, the function is decreasing. After 0, it is increasing means, so f is x equal to 0 is a
Negative to
point of, x equal to 0 is
local
a
minimum.
point of local minimum. X equal to 0 is a point of local minimum. See, of course, the theorem states that if the function is differentiable, then at local minimum or local maximum value, the derivative will be 0. Here the function is not differentiable. Mod x function is not differentiable. So therefore, the derivative is does not exist at x equal to 0 actually. Is it not? If the function is differentiable, then at local maximum or local minimum, derivative will be 0. But here at x equal to 0, there is a local minimum value, but the derivative does not exist because the function is not differentiable. Okay, x equal to 0 is a point of local minimum, and local minimum value is f of 0. What is f of 0? Tell me. In the original function 2 into mod x, if you put x equal to 0, so 0.
0 only, sir.
The local minimum value. So there is only one local extremum, that is local minimum at x equal to 0, because in the entire domain from -1 to 6, -1 to 0, the function is decreasing. From 0 to 6, it is increasing. So at x equal to 0, clearly local minimum is there and the local minimum value is 0. Next, what else we have to find? F of what? -1 and f of 6 at the endpoints of the interval. So what is f of -1? Tell me. Put x equal to -1 in the given
2, sir.
definition.
2,
2 into mod -1, 2. And what is f of 6?
12, sir.
12. So now you have to compare the three values. Local minimum value at x equal to 0, 0. And f of endpoints, f of -1 is 2, f of 6 is 12. Out of them, which is the least value? Tell me. 2, 12, and 0. Which is the least
0,
value?
Sir.
Come on.
0, sir.
0. 0 is the least value. Therefore, the absolute minimum value of the function is 0. This is absolute minimum. Okay. Out of the three values, which is the greatest value?
12, sir.
12. So this is the absolute maximum value. Absolute maximum or global maximum or greatest value, whatever. Understood? So this is an example of a function which is not differentiable in the given domain. Okay. At one point of the given domain, it is not differentiable. At there, it is having local minimum. And that local minimum is the global minimum also for this function. Okay. Let us see the next question. Fourth one. F of x is equal to sin x plus cos x. F of x is equal to sin x plus cos x on closed interval 0 to pi. Come on, let us first find the local maxima and local minima. F dash x is what? For sin x?
Cos
Come on.
x, sir. Cos
Cos
x
x.
minus sin x.
For
Cos
cos
x
x minus sin x. This we have to equate it to 0. Implies cos x is equal to sin x.
Sin x.
Implies tan x equal to 1. Is it not? Sin x by cos x, tan x equal to 1. Tan x equal to 1 in the interval 0 to pi. For what value? Come on. 0 to pi by 4.
Pi by
0 to pi,
Okay.
first quadrant, and second quadrant, of course, second tan is negative. Okay. So only one value, x equal to pi by 4, that is 45 degrees. There, is it local maximum or local minimum? We have to find out. This is stationary point. For this function, in the given domain, x equal to pi by 4 is a stationary point. Let us see whether it is a turning point also or not. So by taking the second derivative, what is derivative of cos x? Minus sin
sin
x.
x.
What is the derivative of
cos x.
minus sin x?
Minus cos x.
Minus cos x. So we have to find the value of the second derivative for what value of x? Come
Pi
on.
by 4.
Pi by
by
4,
4.
where the
By 4.
derivative is 0. Put x equal to pi by minus sin pi by 4 minus cos pi by 4. So minus 1 by root 2 and again minus 1 by root 2. We want its sign only, not the exact value. This is clearly negative. Second derivative negative means local maximum
Local
or
maximum.
very
Maximum.
good. Local maximum. Second derivative negative means local maximum. So local maximum value of the function is f of pi by 4. In the original function, you put x equal to pi by 4. Here, sin x plus cos x. Sin pi by 4, 1 by root 2 plus cos pi
1
by
by
4,
root
another 1 by root 2, 2 into 1 by root 2, root 2. This is the local maximum value. Now, what else we have to calculate? Come on, anybody?
So at the end,
Absolute
at the end
maximum
values
End
of 0
points
and
of the
5.
interval. Correct. At the end points of the given domain. So we have to find the values of what is f of 0? Sin 0, 0 plus cos 0, 1.
1.
So that is 1. Pi. Other end is pi. Sin pi 0
1
plus cos pi minus 1. Cos pi is minus
Minus
1. Minus 1.
minus
So
1.
out of the three values, which three values? The local minimum value, endpoints, all the three we have to consider. So which is the least one?
Minus 1. Sir.
Minus 1. So this is absolute minimum. This is absolute minimum value or global minimum value or greatest value of the function in the given domain. Which is the greatest one out of the three?
Sir, root 2.
sir.
Root 2. So that is absolute maximum value. This is absolute maximum value or global maximum value or the greatest value of the function in the given domain 0 to pi. Okay. All right. Let us see the last bit in this.
Sir,
Ah,
Sir, I have a question, sir.
who is that speaking?
Sir, Shilpita.
Ask your doubt. Express your doubt.
Sir, if we give domain and open interval, how we have to calculate absolute maximum and minimum, sir?
What?
If they give domain and open interval, sir.
If the given open interval, there is no, see, open interval. So then we have to see the limits only. When x tends to 0 plus, when x tends to, so no values will be there, of course. Those values we need not take into consideration. Okay. Only
sir.
the local values you have to take. So any examples are there in the book? Let us see. We'll come do them also. Let us finish the last bit. Okay. Domain is open into, that is a good question, good doubt. Okay. F of x is equal to x plus sine 2x. Let us see whether there are any examples when the given interval is open.
Sir, for the
Or
fifth
otherwise,
one, I got local minimum as 0 and local maximum as pi.
uh,
For this one, I got local minimum as 0 and local maximum as pi, sir.
let
Fifth
us see. Let us see. Who is that speaking?
Aditya, sir.
Aditya, let us see whether your answer is correct or not.
Okay.
F of x is equal to x plus sine 2x on closed interval 0 to pi.
Pi.
Right. Of course, here algebraic functions and trigonometry function combined. Okay. So what about f dash x? For x,
So
the
1 plus
derivative is 1. For sine 2x, the derivative is
Cos 2x.
2 cos 2x.
Cos 2x.
cos 2x into 2.
2.
Cos 2x into 2. Okay. 2 cos 2x. Okay. This we have to equate it to 0. Implies cos 2x is equal to minus 1 by 2.
1.
Minus 1 by 2. See, the given interval is 0 is less than or equal to x, less than or equal to pi, including both 0. Now 2x here, cos 2x, not cos x. Let us multiply by 2. 0 multiplying by 2, you get 0 less than or equal to 2x, less than or equal to 2 pi. So 2x takes values from 0 to 2 pi, both including. In this, so for what values of 2x? The cos 2x is minus 1 by 2, 120 degrees
120 degrees.
and 240 degrees. 120 and 240 in the second and third quadrants. Of course, first and fourth quadrant cos x is positive. So this implies 2x must be either 2 pi by 3, that is 120 degrees, or 4 pi by 3, 240 degrees. Dividing by 2, you get x is equal to pi by 3 or 2 pi by 3. So we have got two stationary points here. Okay, let us use another color, red color. Stationary points. These stationary points are the turning points. Turning points means where the first
Sir, we
derivative
don't know yet,
changes its sign. So we
We don't
can
know.
find by using the second derivative test. What about f double dash x? For
0
1 plus 2 cos 2x, what is the derivative? Minus 4 sine 2x, is it not?
Yes,
Right or
sir.
wrong?
Yes, sir. Yes, sir.
Right or wrong? Tell me.
Yes, sir.
Correct only, sir.
Yes, sir.
Minus 4 sine 2x is the derivative. Now this second derivative sign we have to find at pi by 3 and 2 pi by 3. So f double dash pi by 3. minus 4 sine 2 pi by 3. X value I am putting pi by 3. Sine 2 pi by 3, that is sine of an angle in the second quadrant. Second quadrant sine is positive, but minus 4 is there, so it is negative. You need not calculate the actual value, positive or negative. Negative means what? Second derivative negative means local
Maximum.
maximum. Local maximum. Similarly, f double dash 2 pi by 3. Here I have to put in place of x 2 pi by 3 minus 4 sine 2 into 2 pi by 3, 4 pi by 3. 4 pi by 3 means 240 degrees. 240 is an angle in the third quadrant. Sine is negative. Negative into negative, positive. Okay. Second derivative positive means local minimum.
Minimum, sir.
Okay, positive.
Second derivative positive means local minimum. So, what is the local maximum value? Local maximum value, we have to put x equal to what? Pi by 3. Pi by 3 in the original function. So, x equal to pi by 3. Pi by 3 plus sine 2 pi by 3. Sine 2 pi by 3 means sine 120. Sine 120 is equal to sine 60 root 3 by 2. Right. Now, local minimum value, this one. This is an important question. This is a very good question, important. Local minimum value, we have to calculate what? F of 2 pi by 3.
2 pi by 3.
X equal to 2 pi. So, x equal to 2 pi by 3, I have to put there. Plus sine 4 pi by 3. 2 into 2 pi by. Sine 4 pi by 3, sine 240 minus sine 60 minus root 3 by 2. Minus root 3 by 2. Okay. Next, these are the local maximum and local minimum values at the endpoints of the interval. 0 and pi. What is f of 0? This is f of pi by 3.
Yes, sir.
Local maximum value, and local minimum value is f of 2 pi by 3. Now we have to see the values of the end of the interval domain. F of 0 is what? X equal to 0, sine 2x, sine 0. 0 plus 0, 0.
0.
So f of pi, other end. X is pi plus sine 2 pi is 0. Pi. So these are the 4 values. Out of these, which are correct? Tell me. Which is the maximum value?
Pi.
Pi is the maximum value. See, pi is 3.14159 by 3. So this is 1 point something. 1 point something. Pi by 3 is 1 point something. Root 3 is 1.732 by 2. 1.732 by 2, 0.8 something. So 1 point something, 0.8 something. And positive value. Here 2 pi by 3 is 2 point something minus 0 root 3 by 2, 0.8. 2 point something minus 0.8, that means 1.2 something. Is it not? So, what is absolute maximum value? Pi only. Pi is 3 point. So, absolute maximum.
So can't we do in degrees, sir? Like I thought 180 by 3 is less than 180 and 2 into 180 by 3 is less than 180. I thought like that.
You should not put 180 for pi.
Okay.
You have to put pi is equal to 22 by 7.
Okay.
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 Pi is not 180. Pi is 22 by 7, approximately 3.14159. Okay. Right.
Okay. Thank you, sir.
This is pi absolute maximum value is pi only, and this 0 is absolute minimum value. So both values are at the endpoints only. Local points are not absolute maximum or absolute minimum. Both points are at the endpoints of the interval only. Okay. Understood? So both points are at the endpoints only. Let us see the answer. I'll see the answer at the end of the book. This is second Roman, first question, fifth bit. First question, fifth bit. Absolute minimum 0, absolute maximum pi. Correct. He has given correctly. Local minimum, local maximum values are nothing. No, none of them is absolute maximum or absolute minimum. Only at endpoints we got the absolute maximum and absolute minimum. Okay. So yesterday I have given some problems for homework. All of you have completed them.
Yes, sir.
Now
Yes.
I'll give some more problems. Finding the absolute maximum and absolute minimum also, you can take these as homework. Yesterday, which problems I have given homework? Kunal,
Yes, sir.
please tell me which problems I have given for homework.
Sir, 1 second, sir.
Anybody else, please?
Can I tell, sir?
Who is that?
Pranav, sir.
Pranav, tell me which are the problems I have given.
Sir, from second question, sir. To
Second
Roman. Second
Ah.
Roman. 2, 3, 4, 5.
Wait. Second
sir.
Roman 2,
3, 4,
Ah.
5, 6, 9 and 10, sir.
6, 9 and 10.
Yes, sir. From third Roman, 1, sir.
Wait. Correct.
Yes, sir.
Wait. So I'll give some more problems now. Say 2, 3, 4, 5, 6, 9 and 10. Third Roman 1. Okay. Now, second Roman, what are the problems left out? 7 and 8. 7 and 8. 7 is very important. I have put 3 stars for it. 7, I have put 3 stars. So that is a very good problem. Find the absolute maximum and absolute minimum value of a cubic polynomial in the interval 0 to 5. 7 and 8 left out, so they can be completed. And third Roman 1 I have given 2, you can take it now. Third Roman 2, find the absolute maximum, absolute minimum value interval. And T3 also, because 3 is find 2 positive integers whose sum is 16 and the sum of whose squares is minimum. So this type of problem I have done in the done from the solved examples. Okay, you can do it. So remaining problems I will do in the class. Third Roman classwork. Third Roman. Third Roman 1, 2, 3 I have given for homework, is it not? Fourth one. Fifth one. Sixth one. 7 and 8. So with these 5, I can complete the chapter. Okay. These are for homework. Homework yesterday. And this is homework today. Okay. And this is all classwork. Okay. Please make a note of them. It is 10 o'clock now, 9:59. So I am going to end the class. In the class, I will finish these 5 questions, 4, 5, 6, and 7 and 8 from the third Roman. With that, the chapter will be completed. And of course, the syllabus also will be completed. How about this tangent and normals? Anybody?
What, sir?
Tangents and normals, sir is teaching in the afternoon, is it not?
Yes, sir.
So which is it being completed?
Yes, sir.
Yes,
Where
sir.
are you? Where are you? You have found the already
Sir,
angle between two curves, orthogonal intersection, that is discussed.
Yes, sir.
Yes, sir.
Angle
Started
between two
yesterday.
curves, orthogonal intersection of two curves. Okay. So that also will be completed. So next week we are going to complete the syllabus. Okay. So, right. So I'll end the class now. It is exactly 10 o'clock. So we'll meet tomorrow again. Thank you very much.
Thank you, sir.
Thank you, sir.
Okay. Okay.
Good morning and thank you, sir.
Okay.
Thank you, sir.
Okay.